Amazon EC2. By the end of this lesson, you'll be able to explain the working of Amazon EC2, discuss the features of EC2, and describe the benefits of the AWS marketplace. Topic 1. Introduction to Amazon EC2. Amazon EC2 is a service that provides virtual computing environments, known as instances. It has pre-configured templates for your instances, known as Amazon Machine Images, or AMIs. These package the bits you need for your server, including the operating system and additional software. There are various configurations of CPU, memory, storage, and networking capacity for your instances, known as instance types. It provides secure login information for your instances using key pairs. AWS stores the public key, and you store the private key in a secure place. Storage volumes for temporary data that are deleted when you stop or terminate your instance. These are known as instance store volumes. And persistent storage volumes for your data using Amazon Elastic Block Store, EBS. These are known as Amazon EBS volumes. Topic 2. Benefits of EC2. Case study: Dow Jones & Company. New York-based Dow Jones & Company is a global provider of news and business information, delivering content to consumers and organizations via newspapers, websites, mobile apps, video, newsletters, magazines, etc. It employs nearly 2,000 journalists in more than 50 countries, and they own the Wall Street Journal, Barron's, MarketWatch, and DJX, its flagship news and analytics platform. In Asia, about 12.8 million people use wallstreetjournal.com, which generates around 90 million page views each month. When the lease on its Asian data center ran out in early 2013, the company needed to find an alternative that would help its developers focus more on revenue-generating applications instead of on data center maintenance. Dow Jones also wanted to reduce latency for its Asia-based customers, and it wanted to avoid delays for acquiring and configuring hardware. Dow Jones chose AWS because it helps enable the company to improve time to market for its products. It took the company about 6 weeks to move from its Hong Kong data center to AWS. WallStreetJournal.com now runs on AWS Tokyo, and it leverages multiple availability zones on EC2 instances to run Dow Jones app code and Oracle databases. Elastic load balancing instances are used to route application traffic between services. Third-party load balancers are used to balance user traffic, and WAN accelerators are used to improve database replication. Dow Jones is also using CloudWatch, IAM, and VPC. Expedia. Expedia uses AWS to run critical and high-volume applications globally. It's all in on AWS, with plans to migrate 80% of its mission-critical apps from its on-premises data center to the cloud in the next 2 to 3 years. By using AWS, Expedia has become more resilient. Expedia's developers have been able to innovate faster while saving the company's millions of dollars. Expedia provides travel booking services across its flagship site Expedia.com and around 200 other travel booking sites around the world. Expedia began using AWS in 2010 to launch Expedia Suggest service, a typehead suggestion service that helps customers enter travel search and location information correctly. According to the company's metrics, an error page is the main reason for site abandonment, and Expedia wanted global users to find what they were looking for quickly and without errors. At the time, Expedia operated all of its services from data centers in Chandler, Arizona. The engineering team quickly realized they needed to run this product in locations physically close to customers to enable a quick and responsive service with minimal network latency. Expedia considered on-premises virtualization solutions as well as other cloud providers, but ultimately chose AWS because it was the only solution with the global infrastructure in place to support Asia-Pacific customers. Using AWS, they were able to build and deliver the ESS service within 3 months. EC2 benefits. EC2 provides scalable computing capacity in the AWS cloud. It eliminates your need to invest in hardware. It enables faster development and deployment of applications. It's useful for launching as many or as few virtual servers as you need, configuring security and networking, and managing storage. It enables scaling up or down to handle changes in requirements or spikes in popularity, reducing your need to forecast traffic. It provides resizable compute infrastructure in the cloud, and it includes one or many instances. Users pay for what they use with no minimum commitment, and it's compatible with familiar operating systems along with cloud benefits. The following graph describes the elasticity of EC2 with regards to server load and the hour of the day it runs. It simplifies your operations, scales as required, improves resiliency, runs applications securely, runs any application, and reduces your costs. This graph shows network traffic on servers throughout 24 hours, with the highest peak at the 12th hour of the day. This graph shows the average capacity or server load of an EC2 server throughout a day. Traditional capacity required when using a data center server is marked with orange, and the actual capacity of the server required to manage the load when using EC2 is marked in blue. Here you can see the elasticity of EC2 servers handling the load during the first 8 hours. And now you can see the EC2 handling load in the following 8 hours. During the peak load, one more additional EC2 instance is added as part of horizontal scaling. It can be done manually or automatically using auto-scaling. When the peak load subsides, we can drop back down to one EC2 instance for the next 8 hours. In a traditional data center model, we would have needed the capacity for all of the 24 hours, so EC2 shows how you can reduce your infrastructure costs. In fact, in this example, you can save 1/3 of your costs when using EC2 rather than the traditional data center servers. One of the most common infrastructure patterns is the 3-tier infrastructure. This pattern divides the infrastructure into 3 separate layers, 1 public and 2 private layers. The idea is that the public layer acts as a shield to the private layers. Anything in the public layers is publicly accessible, but resources in the private layer is only accessible from inside the network. In addition to dividing the network into 3 separate layers, we also want to implement some kind of high availability. AWS allows you to achieve high availability by distributing your application across multiple availability zones. Each availability zone is a physical data center in a different geographic location. Another big benefit of EC2 is that it's secure. It has secure premises, storage, keys, communications, network access, users and logins, and there's full control to add further security. Amazon VPC allows you to provision a logically isolated section of the AWS cloud. You can control your virtual networking environment with subnets, route tables, security groups, and network ACLs. You can connect your on-premises network via a VPN, and you can control if and how your instances access the internet. And here is a diagram that shows EC2 instance deployment when using a VPC. Topic 3. Instances. When you launch an instance, the instance type that you specify determines the hardware of the host computer used for your instance. Each instance type offers different compute, memory, and storage capabilities and are grouped in instance families based on these capabilities. You should select an instance type based on the requirements of the application or software that you plan to run on your instance. Burstable performance instances. T3 and T2 instances are designed to provide a baseline level of CPU performance with the ability to burst a higher level when required by your workload. Burstable performance instances are well suited for a wide range of general-purpose applications. These provide a balance of compute, memory, and networking resources and can be used for a variety of workloads. These instance types are M5, M5A, and M5D, as well as the T2 instances. Compute-optimized instances are ideal for compute-bound applications that benefit from high-performance processors. These are C4, C5, CN, and CD. Memory-optimized instances are designed to deliver fast performance for workloads that process large datasets in memory, and these are the R4, R5, R5A, and R5D instances. Storage-optimized instances are designed for workloads that require high sequential read and write access to very large datasets on local storage, and these are D2, H1, and I3. Windows Accelerated Computing instances. If you require high processing capability, you'll benefit from using accelerated computing instances, which provide access to hardware-based compute accelerators such as graphic processing units or field programmable gate arrays. T1 micro instances provide a small amount of consistent CPU resources and allow you to increase CPU capacity in short bursts when additional cycles are available. They're well suited for lower throughput applications and websites that require additional compute cycles periodically. Instance purchasing options. EC2 provides the following purchasing options to enable you to optimize your costs. On-demand instances. Pay by the second for instances that you launch. Reserved instances. Purchase at a significant discount instances that are always available for a term from 1 to 3 years. Scheduled instances. Purchase instances that are always available on a specified recurring schedule for a 1-year term. Spot instances. You can request unused EC2 instances which can lower your EC2 costs significantly. Dedicated hosts. You can pay for a physical host that is fully dedicated to running your instances, and you can bring your existing per socket, per core, or per VM software licenses to reduce costs. Dedicated instances. Pay by the hour for instances that run on a single tenant hardware. Capacity reservations. Reserve capacity for your EC2 instances in a specific availability zone for any duration. If you require a capacity reservation, purchase reserved instances or capacity reservations for a specific availability zone, or purchase scheduled instances. Spot instances are a cost-effective choice if you can be flexible about when your applications run and if they can be interrupted. Dedicated hosts can help you address compliance requirements and reduce costs by reusing your existing server-bound software licenses. Instance lifecycle. The following illustration represents the transitions between instance states. By working with EC2 to manage your instances from the moment you launch them through their termination, you ensure that your customers have the best possible experience with applications or sites that you host on them. Pending state. The instance is preparing to enter the running state. When it enters the pending state, it launches for the first time, or when it's restarted after being in the stop state. Billing stage is not billed. Running. The instance is running and ready for use. Billing stage is billed. Stopping. The instance is preparing to be stopped or stop hibernated. You are not billed if preparing to stop, but you are billed if preparing to hibernate. Stopped. The instance is shut down and cannot be used. The instance can be restarted at any time, and you are not billed. Shutting down. The instance is preparing to be stopped. You are not billed. Terminated. The instance has been permanently deleted and cannot be restarted. You are not billed. Note that reserved instances that apply to terminated instances are billed until the end of their term according to their payment option. Instance metadata and user data. Instance metadata is data about your instance that you can use to configure or manage the running instance. Retrieving instance metadata. Because your instance metadata is available from your running instance, you do not need to use the Amazon EC2 console or CLI. This can be helpful when you're writing scripts to run from your instance. For example, you can access the local IP of your instance from instance metadata to manage a connection to an external application. To view all categories of instance metadata from within a running instance, you can use the following URL. Note that you're not billed for HTTP requests used to retrieve instance metadata and user data. You can also use PowerShell commandlets To retrieve the URL, for example, if you're running version 3.0 or later of PowerShell, you can use the following commandlet. If you don't want to use PowerShell, you can install a third-party tool such as GNU wget or curl. Throttling. AWS throttle queries to the instance metadata service on a per-instance basis, and they place limits on the number of simultaneous connections from an instance to the instance metadata service. Working with instance user data. When working with instance user data, keep the following in mind. User data is treated as opaque data. What you give is what you get back. It's up to the instance to be able to interpret it. User data is limited to 16 kilobytes. This limit applies to the data in raw form, not base64 encoded form. User data must be base64 encoded. The EC2 console can perform the base64 encoding for you or accept base64 encoded input. User data must be decoded when you retrieve it. The data is decoded when you retrieve it using instance metadata and the console. If you stop an instance, modify its user data and start the instance, the updated user data is not executed automatically when you start the instance. However, you can configure settings so that updated user data scripts are executed one time when you start the instance, or every time you reboot or start the instance. Working with instance user data. Specify instance user data at launch. You can specify user data when you launch an instance, and you can specify that the user data is executed one time at launch, or every time you reboot or start the instance. Modify instance user data. You can modify user data for an instance in the stop state if the root volume is an EBS volume. Retrieve instance user data. You can retrieve user data from a running instance using the following URL. A request for user data returns the data as it is. Retrieving dynamic data. To retrieve dynamic data from within a running instance, use this URL. Instance store versus EBS backed. Instances that use instance stores for the root device automatically have one or more instance store volumes available, with one volume serving as the root device volume. When an instance is launched, the image that is used to boot the instance is copied to the root volume. Note that you can optionally use additional instance store volumes depending on the instance type. Any data on the instance store volume persists as long as the instance is running, but this data is deleted when the instance is terminated. Instance store-backed instances do not support the stop action. Also, if the instance fails, the data will also no longer persist. After an instance store-backed instance fails or terminates, it cannot be restored. If you plan to use instance store-backed instances, AWS highly recommend that you distribute the data on your instance stores across multiple availability zones, and you should also back up critical data on your instance store volumes to persist storage on a regular basis. EBS-backed instances. Instances that use EBS for the root device automatically have an EBS volume attached. When you launch an EBS-backed instance, AWS creates an Amazon EBS volume for each EBS snapshot referenced by the AMI you use. You can optionally use other Amazon EBS volumes or instance store volumes depending on the instance type. EBS-backed instances can be stopped and later restarted without affecting data stored in the attached volumes. There are various instance and volume-related tasks you can do when an EBS-backed instance is in a stop state. For example, you can modify the properties of the instance, change its size, or update the kernel it is using. Or you can attach your root volume to a different running instance for debugging and other purposes. If an Amazon EBS-backed instance fails, you can restore your session by following one of these methods: stop and then start again, or automatically snapshot all relevant volumes and create an AMI. IAM instance profile. An instance profile is a container for an IAM role that you can use to pass role information to an EC2 instance when the instance starts. Here are the steps to attach or replace an existing profile. Open the EC2 console and choose Instances from the navigation pane. Choose the instance that you want to attach an IAM role to. Check the IAM role under the description view of the Launch Instance pane to confirm if an IAM role is attached to the instance. If a role is attached, confirm that changing the role attached to this instance will not affect your applications or access to AWS services. Choose Actions, Instance Settings, and choose Attach Replace IAM Role from the drop-down list. Then under IAM Role, choose the instance profile that you want to attach from the drop-down list. If a role is created using the Amazon EC2 console, the instance profile name and the IAM role names are the same. When you're completed, choose Apply. Welcome for the demonstration about how to launch and connect to an EC2 Windows instance. Firstly, let's navigate to the EC2 dashboard and click on Launch Instance. So here are a list of all the AMIs that are available of all the differing operating systems. Now obviously we want to find a Windows one, so we'll type Windows into the search box, hit return, and here's all the Windows AMIs that are available by default. So we'll click on the first one available. And we're just going to choose the defaults as we progress through here. So we'll click on T2 Micro. We'll accept the defaults for the configuration of the instance. We'll move to add storage. You see here that it's given 30 gigabytes because it's a Windows system, so it needs more space than a Linux operating system. But we'll click on Next, Add Tags, and we'll give it a name. And we're going to give it a name of SL AWS Demo Windows. We'll click on Next, Configure Security Group. We're going to accept the default, which allows us RDP access to port 3389 to all IP addresses. Now obviously it's not a good idea to leave stuff wide open like this, but for this demonstration it's fine. And the review tab shows us everything we've selected, so we could change and edit stuff here if required, but we're just going to click on Launch, and we're going to create a new key pair for this Windows instance. And we're going to call it SL AWS Windows. And remember, you must download it now, otherwise you won't get a chance to do so again. And we'll need this to get the password for the instance. So now we have the file downloaded, we can click on Launch Instance. And we can see our instances are now being launched. And here's the instance ID of our new instance. So if we click on that, it'll take us to the EC2 dashboard and give us some more information. Here you can see the instance is in a pending state, so it's still being launched by Amazon. But in a few minutes it will be available. So now you can see it's available. So if we click on the Connect button, it gives us here some information about our instance. And we want to get the password. So if we click on Get Password, we can then choose the PEM file associated with this instance. And it tells us the name of the key name here in case we'd forgotten. It's worth noting that when you launch a Windows instance, it takes around 4 minutes before you can do this step. So if we choose our file, so we've chosen the PEM file that we'd saved, we click on Decrypt Password, and there we are. There's the password for the administrator login for our new Windows instance. So we can also click on the Download Remote Desktop File button, and that will give us an RDP session that we can click on to automatically connect us to our instance. it asks us for the administrator password, so we can just cut and paste this from the AWS dashboard. Just paste that in and hit OK. And click remember if you don't want to have to type this in each time. We'll click yes. And after a few seconds, there you are. We're being connected to our brand new Windows EC2 instance. Now this instance is going to be a little bit slow because it's a T2 micro. If it were a larger instance, it would probably have sprung to life by now. And there we are, we've established our connection to the Windows EC2 instance. Welcome to the Launch and Connect to an EC2 Linux instance demonstration. So first things first, let's navigate to the EC2 dashboard. So we'll click on Launch Instance to start the process, and we're presented with a list of all the different AMIs of different operating systems that are available. So we're going to click on the Amazon Linux 2 AMI. On the first screen, we're going to keep the default option of a T2 micro. We're going to click Next so we can configure our instance. So here we could make changes to where we wanted to launch the instance, for example, the VPC, whether it's going to have public IP address, the IAM roles, etc. But we're just going to leave it default for now for this demo. Click on Next, then we can edit the storage. So if we want to do, we could change the size, we could add another volume, we could set the encryption levels, but we're going to leave the defaults. So we'll click on Next, and we're going to give our instance a name. So we're going to give it a key of name and a value of . So this will help us identify our instance when it's launched. So we'll click Next to configure the security group. So we're going to accept the default, which allows port 22 SSH access from anywhere, which isn't advised, but we're doing it for this demonstration just for speed. And now we get the review instance page, so we can see everything we've configured. So if something's not right, we can make some changes. So click on Launch. We need to choose a key pair. And we're going to create a new key pair for this demonstration. And we're going to call it SL AWS key 0. And then we're going to download it. And it's important to download it because this is the only opportunity you get to do so. And we'll need this key pair so that we can actually access it from our system. So we'll click on Launch, and we can see that our instances are now launching, and here's our instance ID. So if we click on it, we can see our instance is in a pending state, so it's just being launched, and it won't take very long to arrive. So now we can see it's in a running state, so it's available to connect. So we can click on the Connect button, and it gives us information about how to connect. So if we're connecting via a standalone SSH client, it gives us examples here of how to do it. along with the command we need to run to SSH into the instance. So if we navigate to the download folder, this is where our key pair was downloaded. So if we right click on it, we can launch an SSH session directly from here. There are other ways to do it via PuTTY, for example, but this is one of the easiest ways. So if we paste in the command that was given on the dashboard, hit enter, you can see it saying, "Do you sure you want to continue connecting?" We type yes. It adds this server to our list of known hosts. And we're now connected to our brand new Amazon Linux 2 instance. And that concludes this short demonstration. Welcome to the demonstration on Amazon EC2 instance types. So navigate to the EC2 dashboard. And here is the EC2 dashboard, and we're going to click on Launch Instance. The first option allows us to choose our AMI, and we can choose any of these, but we're going to choose Amazon Linux 2. So we'll click on Select. And now we're presented with the instance type dashboard. Now AWS provides multiple instance types. We can filter by them. If you click on the filter by drop down, you can see all the different groupings of instance types, for example, micro instances or general purpose or memory optimized. Now all of the different instance types come in different configurations, number of virtual CPUs and memory, and the type of instance storage that can be attached to it. So here is all the list of all the different types, and you can choose the instance type that's best suited to your requirement. For example, if you needed just a small instance for some testing, or a low-level application, you could choose a T2 Micro, and this has one virtual CPU, 1 GB of memory, is EBS only, and it has low to moderate network performance. And you can use the filter by to help your search for your instance type requirement. For example, if you just needed a micro instance, you can click on micro instances, and here we can see a T1 Micro, which is one of the smallest available. It has one virtual CPU and around 600 megabytes of memory. So at the top here we can see a high-level overview of the currently selected instance. If you wanted to see more information, you can click on Show Hide Columns, and a list of other options pops up, and you can tick on these to add these into the display. This makes it easy to compare instances if you're stuck between a few different choices. If you wanted to verify how much it's going to cost you, you can navigate to the EC2 dashboard, and on the right hand side click on Pricing, and then on Instance Types. So you can see the prices on the Pricing tab, and on the Instance Types tab you can get more information about the particular instance types. And there's lots and lots of information here for you to read up on regarding all the different instance types. And there's lots of differences, so you need to check to make sure what's more suitable for what your requirements are. Welcome to the demonstration on Amazon EC2 instance types. So let's navigate to the EC2 dashboard. And here is the EC2 dashboard, and we're going to click on Launch Instance. The first option allows us to choose our AMI, and we can choose any of these, but we're going to choose Amazon Linux 2. So we'll click on Select. And now we're presented with the instance type dashboard. Now AWS provides multiple instance types. We can filter by them. If you click on the filter by drop down, you can see all the different groupings of instance types, for example, micro instances or general purpose or memory optimized. Now all of the different instance types come in different configurations, number of virtual CPUs and memory, and the type of instance storage that can be attached to it. So here is all the list of all the different types, and you can choose the instance type that's best suited to your requirement. For example, if you needed just a small instance for some testing or a low-level application, you could choose a T2 Micro. And this has one virtual CPU, 1 GB of memory, is EBS only, and it has low to moderate network performance. And you can use the filter by to help your search for your instance type requirement. For example, if you just needed a micro instance, you can click on micro instances, and here we can see a T1 micro, which is one of the smallest available. It has one virtual CPU and around 600 megabytes of memory. So at the top here we can see a high-level overview of the currently selected instance. If you wanted to see more information, you can click on Show Hide Columns, and a list of other options pops up, and you can tick on these to add these into the display. This makes it easy to compare instances if you're stuck between a few different choices. If you wanted to verify how much it's going to cost you, you can navigate to the EC2 dashboard, and on the right hand side click on Pricing, and then on Instance Types. So you can see the prices on the Pricing tab, and on the Instance Types tab you can get more information about the particular instance types. And there's lots and lots of information here for you to read up on regarding all the different instance types. And there's lots of differences, so you need to check to make sure what's more suitable for what your requirements are. Topic 4. AWS Marketplace. A paid AMI is an AMI that you purchase from a developer. Launching an instance from a paid AMI is the same as launching an instance from any other AMI. No additional parameters are required. The instance is charged according to the rate set by the owner of the AMI, as well as the standard usage fees for the related web services. For example, the hourly rate for running an M1 small instance type. Additional taxes might also apply. The owner of the paid AMI can confirm whether a specific instance was launched using that paid AMI. A shared AMI is an AMI that a developer created and made available for other developers to use. One of the easiest ways to get started with EC2 is to use a shared AMI that has the components you need and then add custom content. You can also create your own AMIs and share them with others. Selling your AMI. You can sell your AMI using AWS Marketplace. The AWS Marketplace offers an organized shopping experience. Additionally, AWS Marketplace also supports AWS features such as EBS-backed AMIs, reserved instances, and spot instances. The AWS Marketplace is a curated digital catalog that makes it easy for customers to find, buy, deploy, and manage third-party software and services that customers need to build solutions and run their businesses. It also includes thousands of software listings from popular categories such as security, networking, storage, and machine learning, and many more. It also simplifies software licensing and procurement with flexible pricing options and multiple deployment methods. Using AWS Marketplace as a subscriber, you can visit the AWS Marketplace to search or navigate to a product that runs on Amazon Web Services. The software can be available in many forms, including AMIs and software as a service products. When you choose a product, you're taken to the product's listing page. Using it as a provider, you need to visit the AWS Marketplace Management Portal to register. If you charge for the use of your product, you must also provide tax and banking information as part of your registration. You create a profile for your company or yourself that is discoverable on the AWS Marketplace. The benefits of the AWS Marketplace are that you can find and deploy quickly. No procurement of hardware and software launches pre-configured for AWS use. It takes minutes for deployment instead of weeks or months. It's vetted, tested, secure, and offers approved products. You have one bill. You use your AWS account to purchase, and it supports invoice billing. You can see charges for software and AWS services separately. And it provides simple purchasing. Clear pricing for all products, hourly and monthly options, different instance size and region choices, tools to track your purchases and control usage, and the ability to scale your software up or down on demand. Welcome to the demonstration for EC2 purchasing options. So let's first move to the EC2 dashboard. And here's the EC2 dashboard page. And on the right hand side, there's a tab for pricing. So if you click on that, it takes you to the AWS webpage for Amazon EC2 pricing. And this provides a documentation for all of the different purchasing options you have for EC2, like on-demand, spot instances, etc., as well as reserved instances and dedicated hosts. So you can review the options provided and choose the one that best fits your business need. So if we go back to the dashboard, click on instances. So if we launch an instance from this instance tab, it will provide us with an on-demand instance type. So the first page would be to choose an AMI. So from here, this would give us an on-demand instance that we pay only for when we're using it. If we go back to the EC2 dashboard, and if we click on the Spot Instances tab, and this takes us to the page where we have spot instances, and we can request spot instances. Now with spot instances, you can bid on EC2 on-demand prices, so you can often get away with paying much less than you would for an on-demand price. The caveat being that if the price spikes, then your instance will get terminated. So here is how you would do it. You can select where you want to put it, what key pair, etc. And there's a variety of different options, but if we scroll to the bottom, and you'd click launch after you'd put your bid in to create a spot instance. So we can see our spot request has been successfully created. And we can see here our spot instance is listed here and it's active. And its status is pending fulfillment. So although the request is active, we haven't got any instances created for that request yet. Now if we take a look at reserved instances, you can buy reserved instances to get huge cost savings on your on-demand instances. You can get up to anywhere between 20 to 50, 60% off an on-demand price by paying upfront for periods of 12 to 36 months. So using this dashboard, you can choose your platform, instance type, tenancy, etc. And you can see here all the prices, and you can compare that to see how much you would save with an on-demand price. And this is how you'd go through, and you'd click purchase to buy that instance. And once you have a reserved instance in your account, you can run an instance of that type and you won't have to pay for it, because you already will have paid for it. And the last one to look at is dedicated hosts. And this is actually a physical server with EC2 instance capability dedicated for your use, and it allows you to launch EC2 instances on it. Now you do this if you needed absolute guaranteed low latency between your applications and instances, or maybe you had some business or compliance requirements that needed a dedicated host. So this is how you'd allocate a dedicated host. You can see now it's available. And we can use this dedicated host to launch our own EC2 instances on top. Key takeaways. You are now able to explain the working of EC2, discuss the features of EC2, and describe the benefits of the AWS marketplace. CloudFront. By the end of this lesson, you'll be able to describe CloudFront and its features. You'll be able to explain edge locations, differentiate between web and RTMP, and implement a CloudFront distribution. Topic 1. Introduction to CloudFront. Amazon CloudFront is a web service that speeds up distribution of your static and dynamic web content, such as HTML, CSS, JavaScript, and image files, to your users. CloudFront delivers your content through a worldwide network of data centers called edge locations. CloudFront works seamlessly with services including AWS Shield for DDoS mitigation, Amazon S3, Elastic Load Balancing, or EC2. There are several reasons why a CDN could benefit your website and company. Performance. Content is cached around the world. Shortest distance to users will not only reduce latency, but also minimize packet loss. Scalability. Offloading traffic to a CDN will make it easier to manage traffic and scale up or down within a short time. Reliability. Requests are always routed to the nearest available location. Lower cost. CDN requires less self-managed infrastructure and makes it easier to reduce cost. And SEO improvement. Page speed is a key factor when it comes to page ranking. Edge locations. An edge location is where end users access services located at AWS. They are located in most of the major cities around the world and are specifically used by CloudFront to distribute content to end users to reduce latency. It is like a front end for the services we access, which are located in the AWS cloud. Edge locations are used for static content delivery, which is part of the AWS CDN service. Static content is replicated to those locations in order to reduce latency for delivery. There is no compute going on in edge locations, just storage of data. AWS DNS servers also sit in edge locations. CloudFront components. Here are the following components that make up CloudFront. Distributions. These are the set of rules that control how CloudFront will access the content you want to deliver. Origins. These are the sources of the content. Behaviors. There's many different behaviors you can use, but some are path and pattern matching, origin selection, headers, and query strings. Restrictions. There are many ways to restrict your CloudFront CDN, for example geographical restriction or whitelist or blacklists. WAF Web ACLs offer Layer 7 application protection. Edge locations, which we've already discussed. There are numerous edge locations distributed around the world to serve users' content. and price classes. You pay per use, and the price is different regarding the geographical region that you're located in. CloudFront distributions. When you want to use CloudFront to distribute your content, you create a distribution and choose the configuration settings you want. For example, your content origin. That could be the Amazon S3 from which CloudFront gets the files to distribute. You can specify any combination of up to 25 Amazon S3 buckets. Access. Whether you want the files to be available to everyone or restrict access to some users. Security. Whether you want CloudFront to require users to use HTTPS to access your content. Cookie or query string forwarding. Whether you want CloudFront to forward cookies or query strings to your origin. Geo-restrictions. Whether you want CloudFront to prevent users in selected countries from accessing your content. And access logs. Whether you want CloudFront to create access logs that show viewer activity. Web versus RTMP distributions. You can use web distributions to serve the following content over HTTP or HTTPS. Static and dynamic download content, multimedia content. However, you can't serve Adobe Flash multimedia content over HTTP or HTTPS, or a live event such as a meeting, conference, or concert in real time. For web distributions, your origin can either be an S3 bucket or an HTTP server, for example a web server. RTMP distributions stream media files using Adobe Media Server and the Adobe Real-Time Messaging Protocol. An RTMP distribution must use an Amazon S3 bucket as the origin. CloudFront integration. Step 1. Setting up your Amazon S3 and CloudFront accounts. To access any web service AWS offers, you must first create an AWS account. This account is required to use any of the AWS products. Signing up provides you with a couple of access key identifiers which are required to sign up for S3 and CloudFront. Step 2. Creating your Amazon S3 bucket. Now you're getting into the coding aspect of setting up the service. You can develop your applications in any number of programming languages and access the Amazon Web Services. Step 3. Creating your CloudFront distribution. In order for CloudFront to know where the origin server is located, you need to create a distribution. Step 4. Preparing the links. The easiest step of the entire process is to create the links using the domain name. CloudFront distributes content with low latency and high data transfer speeds. To estimate the cost of CloudFront, the following points need to be considered: data transfer out, requests, and traffic distribution. Traffic distribution. The price varies across the geographical region. With requests, this relates to the number and type of requests. And data transfer out, this relates to the data transferred out of the customer's CDN edge locations. CloudFront uses an on-demand pay-for-use elastic pricing, and the same price for static and dynamic content. There are usage commitment options and a gigabyte delivery model. Uses of CloudFront. Using CloudFront can help you accomplish a variety of goals. This section lists just a few. You can accelerate static website content delivery. CloudFront can speed up the delivery of your static content, for example images, style sheets, or JavaScript, to viewers around the world. Serve on-demand or live streaming video. CloudFront offers several options for streaming your media to global viewers, both pre-recorded files and live events. For on-demand streaming, you can use CloudFront to stream in common formats such as MPEG-, Apple HLS, Microsoft Smooth Streaming, and CMAF. For broadcasting a live stream, you can cache media fragments at the edge so that multiple requests for the manifest file that delivers the fragments in the right order can be combined. This reduces the load on your origin server. You can encrypt specific fields throughout system processing. When you configure HTTPS with CloudFront, you already have secure end-to-end connections to origin servers. When you add field-level encryption, you can protect specific data throughout system processing in addition to HTTPS security, so that only certain applications at your origin can see the data. Serve customized content at the edge. Running serverless code at the edge opens up a number of possibilities for customizing the content and experience for viewers at a reduced latency. For example, you can return a custom error message when your origin server is down for maintenance, so viewers don't get a generic HTTP error message. Or you can use a function to help authorize users and control access to your content. Serve private content using Lambda at Edge customizations. Using Lambda at Edge can help you configure your CloudFront distribution to serve private content from your own custom origin as an option to use signed URLs or signed cookies. Welcome to this demonstration on CloudFront and pulling data from S3. So what we're going to do is learn how you can use CloudFront to pull data from S3 buckets. So we'll navigate to the S3 dashboard and we're going to create a new bucket. So we're going to call it AWS CloudFront Lab. I'm going to keep it in North Virginia region. So let's add some files to the bucket. So we'll click on Upload and add some files. So I'm just going to drag all these files in and upload. This is basically a basic website template I'm pushing into the bucket. So we'll be using all this content to display our web page. So let's take a look at the index. We're going to index.html file. So if I click on the URL, we're going to go because by default our bucket is not public. So instead we're going to do this via CloudFront. So we'll go to the CloudFront dashboard. And we're going to create a new web distribution. And web distributions are used to speed up distribution of static and dynamic content, for example, HTML, CSS, PHP, or graphics files. So let's click on Get Started. And in the origin domain name, we're going to find our bucket, which is AWS CloudFront Lab S3 Amazon.aws.com. In this demonstration, we're going to leave everything as the default. But there's a multitude of things that can be changed here. So we'll click on Create Distribution. So you can see our distribution here is in progress. And it takes around 10 minutes, sometimes longer, for this distribution to be created. But what you can see here is the domain name that's been allocated to our distribution, and we'll be able to use this domain name to access the files in S3 via CloudFront. So we can see our CloudFront distribution is now deployed, in the status of deployed, so it's ready to be used. So I'm going to take a copy of the CloudFront domain name and I'm going to move to the S3 console and change the public access setting for the bucket and for all of the objects in the bucket. As you can see, we're still getting an error because there's no public access to this file. So let's click on the Permissions tab, Public Access Settings, we'll click on Edit, and we'll uncheck the block and remove public settings. So we'll click on Save and we'll click on Confirm. We'll type Confirm into the box to say we know what we're doing. So that makes the bucket public, but we need to click on all the objects and make them public because they were added when the bucket was not public. So now if I try and access the index.html URL, there you are, we get the web page. So what we want to do is replace the domain name, the Amazon Bucket domain name, with our CloudFront domain name. So if I cut and paste that in, so if I now hit return, you'll see we see the same web page, and this web page is now being served from the closest CloudFront edge location to our location. So that shows how you can use CloudFront domain names or CloudFront distributions to serve your content from S3 buckets. Welcome to the demonstration for CloudFront with an elastic load balancer. So now we're going to set up a CloudFront distribution for our web server. So let's click on CloudFront and go to the CloudFront dashboard. So click on Create Distribution, and we have two options. There's the web distribution, which is perfect for HTML websites, sending graphics and things like that. And then there's the RTMP distribution, which is for streaming media. We're going to choose the web distribution. So click on that. We need to select the origin domain name, and you see we automatically get a selection of things appearing. And we can use our elastic load balancer as the domain. We could have used an S3 bucket as well and some other things, but we're going to use the elastic load balancer. Now we're going to leave most of the settings as their defaults. So for this demonstration, we don't need to look at those, but you can see there's a multitude of options here available. Under distribution settings, we can choose various things where we want our edge locations to be. So we can use all edge locations, but obviously this gives best performance no matter where you are in the world, but it's the most expensive. If your traffic is only coming from, say, USA, Canada, and Europe, then it makes sense to select that one to save CloudFront distribution costs. You can provide alternate domain names or CNAMEs, so you can use different domains instead of the CloudFront domain that you'll be provided with. And as SSL certificate, we can choose our own SSL or we can use the default provided one. And there's here some more settings like default root object or logging or enabling IPv6. We're going to leave everything as the default for now. Now click on Create Distribution. And we'll see our distribution is in an in-progress state. Now it can take up to 15 to 20 minutes for a CloudFront distribution to be created, so it does take a while. Now we can see our status has changed to deployed, so this CloudFront distribution is in operation. So if you take note of the domain name that's provided as part of this distribution, we can cut and paste this into a browser window. And we get the same result. So now we can see the CloudFront distribution is pulling the data from the elastic load balancer, which is serving traffic from the web server. The difference here now is that the data is being pulled from the closest edge location to the browser's location. And we can now browse using HTTPS because CloudFront has an SSL cert associated with it. If you click on the ID of the distribution, you can see all the different information that's available to be changed. Key takeaways. You are now able to describe CloudFront and its features. You can explain edge locations, differentiate between web and RTMP distributions, and you know how to implement a CloudFront distribution.